Welcome to this presentation on implementing submodel template time series data using fast service. The submodel time series data is an upcoming extension to the asset administration shell specification for integrating time series data into the AES. The figure shows the UML meta model of the submodel template. Central element is the time series submodel, which contains metadata information about the structure of the data, as well as a collection of so-called segments. A segment is considered a collection of data points called records, with some optional metadata such as start and end time of the contained data, a description, or additional information about the sampling process used to create the data. Submodel template time series data distinguishes three different types of segments: internal segments, where the data is stored in the AES itself; external segments, where the data is stored inside a file; and linked segments, where the data is stored in an external database. As any file formats in external database systems are allowed to be used, accessing the data would be a rather complex and cumbersome task for any client interested in reading the data. To address this issue, the submodel template time series data define 4 operations on submodel level, shown in blue, that allow the user to access data without needing to care about how the data is actually stored. The implementation and logic how to deal with all different kinds of external and linked segments has to be addressed by the AES implementation framework, in this case fast service. To achieve this, fast service first introduces a new interface called submodel template processor that allows to execute special logic for a given submodel depending on its semantic ID. This approach is not limited to processing submodels of the time series data template. For the submodel template time series data, we provide an implementation called time series submodel template processor, which is responsible for fetching data from different segments. To follow the fast service approach of easy extensibility, this processor again defines an interface called segment provider, which currently has 2 implementations: internal for accessing internal segments and InfluxDB for accessing linked segments stored in an InfluxDB server. Now let's look at an example how this works. Let's assume we have some time series data with the values x of type integer and y of type double. We have data from 2022 that is archived in an external InfluxDB database as shown on the top right. For simplicity, let's limit the data to 3 entries, with 1 for each of the first day of January, February and March. The more recent data from 2023 should be stored in the AES itself rather than an external database. As always, fast service needs to be started with an AES model and a configuration file. On the left, we see an example model containing one submodel that realizes the submodel template time series data. First, we see that it contains a metadata object defining the data structure of this time series, the data points x and y of our time series data and the corresponding data types. After that, we see that the submodel contains 2 segments, a linked segment and an internal segment. Linked segment only contains the endpoint and query needed to fetch the data from the database and no actual data. The internal segment contains a record with x equals 10 and y equals 1.0 from January 1st, 2023. In the bottom right, we see the part of the fast service configuration relevant for activating and configuring the time series submodel template processor. To fetch the data of the linked segment stored in the InfluxDB, additional information such as the credentials to the database is required. This information is stored in the configuration as shown, and the correlation between the linked segment and the corresponding configuration is established via the matching endpoint URL. Keeping this information outside of the AES is essential, as it also contains sensitive information such as passwords, which should never be accessible via an AES. Upon starting with the shown model and configuration file, fast service will identify the submodel as an instance of the submodel template time series data and generate the operations. Users can now use these operations to access the data in the time series in a unified way without having to deal with different databases or file formats. Now let's see this in action. In the background, we already started the InfluxDB server and the fast service. We are now using an HTTP client to communicate with the Digital Twin API of the fast service. First, we're going to fetch the submodel description via HTTP GET. Here we can see that the submodel contains the metadata information with X of type integer and Y of type double. It also contains a set of segments. First, our internal segment containing one record of January 2023 with X equals 10 and Y equals 1.0. The submodel also contains a linked segment with the endpoint pointing to our database and the query string. We also see that the submodel now contains the auto-generated operations, read segments and read records, both taking an input parameter called timestamp of type range. We can also have a look at the content of the database by executing the query via the InfluxDB command line tools. We see that it actually contains 3 records from 2022 as expected. We now switch back to our HTTP client and try reading all records from 2023. For this, we use HTTP post to the operation which is located on submodel level as shown before and set the min and max value of the timespan parameter accordingly. When executing, we get back a list of records which in this case only contains a single record from our internal segment as expected. Let's see if we can also access the data from the InfluxDB. For this, we set the time span to the start and end of 2022 and execute the operation. As a result, we again get a list of records, this time only containing the 3 records from the linked segments /InfluxDB. As a final test, we remove any time filters and return all records from this time series. As expected, we now receive the 1 record from the internal segment from 2023, as well as the 3 records from 2022 from the linked segment /InfluxDB. This shows that a user can access all data from an AES time series without knowing the details where the data is actually stored or how to access it by simply using the operations auto-generated by fast service. Let's summarize. Submodel template time series data defines a meta model for storing time series data and corresponding metadata, and it defines operations to access data from different sources such as databases or files in a unified way. Fast service, on the other side, implements the submodel template time series data. It auto-generates the operations for a unified access to the data and provides interfaces for all types of segments. Fast service also stores database credentials in the configuration file, that means outside of the AES and therefore not accessible by the users, and provides a default implementation of the segment provider interface for linked segments stored in InfluxDB. That's it for now on implementing the submodel template time series data using fast service. Thank you for watching.